Hi, Keith Van Wimmer here, VanTek Consulting. Today we're going to talk about these guys. These are quick change adapters for Anritsu, Yokogawa, JDSU Viavi, and I'm sure there's some others. These are probably my least favorite thing and my most favorite thing. So, yeah, I know that's a little confusing. I'm conflicted about that. So here's the deal. I love Viavi JDSU equipment. I've been using it for 20 years. I'm not endorsing them as far as, paid endorsement or anything like that. I don't get any demo equipment or anything like that. Everything, all my equipment that I use in training and for field testing, it's bought and paid for by me, by the VanTek Consulting, and no freebies. So there's my disclosure. That said, I love JDSU Viavi stuff. Like I say, I've been using it for 20 years, and it's great test equipment. I mean, there's other good test equipment manufacturers out there, Anritsu and AFL and VX. They're all fine. They're just not my choice. That said, as much as I love them, I absolutely hate these. And it's not because they don't work. It's because the fact is that if these fail, if somebody comes out and it gets broken, or for some reason it just wears out, you have to buy a new one. And these guys range in price anywhere from basically $50 on up to $200. It just depends on who has them and how much they want to charge for them. So there's a couple different types of these, not as far as, they're all SC, but from my understanding, there's some that are manufactured in Japan, and I'm going to guess that that's the ones that are the Viavi or Anritsu OEM equipment stuff, and then there's some that are manufactured in China. That's not to say that the OEM stuff isn't coming out of China, but here's the deal. The Chinese ones tend to be a little bit different. In other words, the plastic that they use for the inserts seems to be a little bit softer. Now this insert here, this guy here, the insert down in there, that's the problem. So it gets worn, and once that gets worn, this is useless. The connector pops out of there. Doesn't hold fast, and basically you get high reflectance at launch on your OTDR. Your OTDR shot's bad. You have to go back out and retest. All these wonderful things. With all the testing and training that I do, I go through these a lot. I have a bunch of these just sitting here, just waiting for, in case one of these fails, I can change it out. And that kind of bothers me. And so I looked around, started out about a year ago, I started looking for a way to just replace this insert. This is all we need, is that guy right there, that insert. And so I went and tried to source this, and I haven't been able to find anybody. Obviously they're made, I just cannot find a source for them. So I went on my quest. We have all this wonderful technology now, 3D printing, and so I'm just going to go out and get myself a 3D printer, and I'll just draw this up in 3D CAD, and boy, oh howdy, I'll make a new one. So a year later, and many tries later, we actually have, lo and behold, a working model. Now, I'm just going to show you here. This is about 2 months worth of work of printing, trying, modeling, adjusting, tweaking, that type of stuff. And if you've done anything with 3D printing, you know that the way the layers lay down, there's certain ways that this is not exactly the strongest stuff, And so the problem is that we had to take whatever design and how these were designed and rethink it, basically. And, go through a bunch of different materials and, PLA and nylon and all kinds of stuff. And what's happened is, because of this COVID lockdown and all that wonderful fun stuff, as I've had a lot of time to focus on this and find the perfect mix of 3D printer setup, print head size, plate, build plate temperature, material, the whole shot. And I have now got a repeatable 3D printable insert. Let's talk about what happens with these inserts and why these go bad. It's my opinion that the cause of most of our field failures is because of these guys. These are APC connector, the tips for the scope. And basically what happens is when this gets jammed in, it dents or compresses the plastic or damages that in some way. So let me give you a demonstration of what I'm talking about. We have an insert here, and this is the body. So let's just kind of go back to the beginning. This body is made up of a few components. We have the body of it, the bail. Then we have, I'm going to zoom in here for you. We have the body. So this guy here houses everything. We have a ceramic tube. So most of the work in this connector is done by this little guy, this ceramic tube. This is your alignment tube, and this is what basically, the ferrule slides into, and that's what aligns the ferrules. So this is a really tight fit on the ferrule, so it's what's actually doing all the alignment. This is your ceramic tube holder, I guess we'll call it, or alignment tube fixture. Got 4 screws and an insert, and this is all that is to it. In order to rebuild these, the first thing is you need an insert. Okay, so we've got that. I've gone ahead and machined out and made some little fixtures for myself. So these are like little wrenches. You got to put this in. Once that goes through there, and again, one of the critical parts on these things is this center hole, right? So if it's not centered or off-centered, then basically it's not a matter of the ferrule's not aligning, it's a matter of shoving the connector over to one side and putting more stress on one leg than the other leg. So we got that in there. We'll start this and give that a snug. Let's kind of look at what's going on here since we have this out. So the way the SC connector, this is called a subscriber connector, an SC. Some people like to call them snap clicks. So the housing of this, we have a couple parts here. We have the body, the ferrule, and then we have the housing. And so when these guys go in, it goes past that, and these little guys, the little legs or towers there, will go into the sides there and sit in there. So these flat edges here, the dogs on there, will clamp on to this guy. So if you put this in, they go in there, and again, I'm kind of pushing up on this so that it'd be flat like it was in the base plate. So these guys, as those are pushed in, it clamps onto those little shelves or lips or outcroppings or whatever you want to call them, these little guys here, right there. And so they go in, latch on there, hang on to it, and it's able to take the pressure. Okay, everybody good with that? Perfect. All right, so here's what happens. We know that we need to inspect our connectors every time, right? So I'm going to go ahead and put it in my little flattening fixture. So what happens is when you put this in an SC type of barrel, as it goes in, there's a groove here. So these guys can kind of relax. They don't go through a lot of tension as it goes in and out. It just kind of snaps in there. All right. So with the advent of GPON and the utilization of the APC connectors, and I'm a big fan of APCs. I love them. I think they're great. I zero reflection off some of these things. It's amazing. We still need to scope those. So what happens is, as this guy goes in and he pushes in, there's a big area that's sitting and putting stress and strain on these guys and pushing against them. All right. What happens is, as this goes in, it puts a lot of pressure on these. And so especially when you're 3D printing, it was causing them to snap off and break, right? For the standard inserts, the injection molded ones, those are probably high density polyethylene, HDPE. It dents those and causes it to kind of, you know, round out like this. Now the problem is, as we all know, is if you have material there and it gets pushed out, you know, it's got to go somewhere. It doesn't just disappear. It's not cut out, it's pushed, right? And so as that smears out there, it starts to cause problems with the shelves, things like this, and we get into an issue with bad retention. So these guys here, the reason that we can't do a groove in this is when you look at this guy, you can see that the hole is centered inside there. And this is the camera side. This is the, you know, the business end, so to speak. This side here is just the alignment. So when you're doing photography, you have to have your planes have to be parallel, all right? So if you get off angle, if one of those planes is crooked, the light's going to reflect off of it, refract at a different angle. So we're talking about, you know, angle of incidence, angle of reflection. So in order to make the light coming from the camera, so this is the camera side, in order for that light to illuminate the 8-degree angle on an APC, it has to move the camera in line with that connector and make it parallel to the connector end face. To do that, what they've done on this is they've bored a hole in here. Now that hole, if you look up in here, if we can see, let me get this paper over here. So if you look on this side, the line, it's really close to that side of the adapter. And there's a lot of metal on this side of the adapter, the upper side. And that's because they went from the center of this hole, as such, to the center of that one. So look what's happening here. The thickness of the metal on this side is way thinner than the thickness of the metal on that side. We can see that from the inside here, right? So what's happening is we can't put a groove in there, because if we put a groove, we're going to cut into or encroach into the opening here, and then we're going to lose light, and it's just not going to work right. So they had to kind of align this weirdly, right? And they couldn't do anything with this. So again, as this goes in and spreads those, it pushes these back up against the walls here and starts putting pressure on them. And if we know, pressure has to go and get released some way, so it's going to break or get squished plastic or whatever. So we spent, like I say, we started on this project about a year ago, and I was certainly naive about 3D printing. So if you've ever done 3D printing, you know that you've got a print and it comes out, and you know you have to clean it up and take your support out of there and all that fun stuff. And you know, doing these very small parts like this, extremely difficult in 3D printing. So through the time, it wasn't a year solid, it was on and off, but over the year, I would go back after this and adjust and do a 20-minute print, and you know, try it and it would break, and so on and so forth. So what we've got now is we've designed this, made the adjustments, stayed with it. Perfection takes time, it takes perseverance, but we've got this absolutely perfect now. We've done some redesign on the original to specifically work with 3D. And when you take this, all you got to do to rebuild these is obviously take the 4 screws out. Now on a new adapter, those screws are Loctited in there. They used blue Loctite or red Loctite, so it takes a little bit of effort to get the screws out. Once you have the screws out and you've put this in there and configured it as such, all we have to do is drop that in. Once we've dropped it in, go ahead and put our screws in. Now the original screws, if you're lucky enough to have steel screws, these are stainless steel, so they're not magnetic, but if you have steel screws, You can just grab them with a magnet. For this guy, tweezers is a good thing. You know, big fingers, little screws, bad eyes. It's all for makes for great YouTube watching, I'm telling you. Okay. All right, let me find my tweezers. Well, these aren't doing much better. All right. So when you tighten these, you just kind of snug them down at the beginning, right? So you just want to get all the screws in there, and then I don't know. I found that if you over tighten these right at the beginning, you can split the plastic. It's kind of they're chamfered in there, but it does squash some plastic going out. So we don't want to crack these, all right? So just kind of just go diagonally. So now you have to get these screws seated to the correct depth. It has to be basically bottomed out. You know, we're dealing with a 2mm screw, so you don't need to, again, to put 60 pounds on it. But the deal with that is that these have to sit up against this base plate. So this is what's sitting in the OTDR, is this base plate, and on the back there's an FC connector. So inside the OTDR, that's what's in there. Let me take this out. So that's it. All right, it's the base plate there, and that has the pins on it for the bail to attach to. The other thing too is I want to mention is some of the Chinese knockoffs, these pins on the side here can recess back in. They start to go into the body. They're just press fit in there, so you want to watch for that. So, all right. So once we have that, we've got this in there. So when we rebuild these, what we do is we'll take these and go ahead and make sure that the bail is attaching correctly, that that these pins, occasionally I mentioned earlier that these pins, if they get recessed in there, what'll happen is this will kick out a little bit off the side. It'll skew off this way, and that won't give you a good connection. So we'll check those, make sure that's all good. The biggest thing is we'll make sure that when we plug this in that that's working and everything's good on that. And then package this up and send it on out to you, so you get the full Monty there. So now we're actually have these in stock. We're ready to go. We have some printed up and ready to rock. So they're also available in green for APC. Now, for these adapters, we don't recommend doing the green, because if you make it an APC and you put it on a UPC machine, it's going to get a little confusing. So typically the machines have a green band around them that will denote that it's an APC, like when we looked at the OTDR, it had a green cover. If you do have a fixed adapter in your machine and the insert's broken, you can send us the machine and we can go ahead and replace it with the appropriate insert with APC green or blue. So again, that's available. I hope this helps. We'll be sending out an email on this, so if anybody has any interest in getting their adapters rebuilt, we're going to do this in-house to begin with. I just want to make sure that we've done 30 or 40 of these, but I want to make sure that that we have a large number of perfection, I guess is what I want to say, and consistency, before we'll send out just this guy to the customer. So it gives us a chance just to make sure and make sure everything's working correctly. All right. So I hope this has been interesting. Hope to hear from you folks and get your adapters rebuilt and save you some money. So until next time, like, subscribe, give us Facebook, LinkedIn, Twitter, all the usual social media stuff. Join us. So until next time, be safe. We'll see you on the next video. Thanks for watching.